Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about inverse trig functions, and we're going to do a little bit of practice. If you recall from our prior lesson, real quickly, we said that if we have some sine of an angle, then we can figure out the relationships of the sides. But if we just have the relationships of the sides, we can figure out the angle measure. In that case, we're going to use inverse sine to figure out on our calculators, or using what we know about relationships between sides and right angles to figure out the answer. So let's do some practice. Number one, I have the cosine, inverse cosine is equal to 0. Well, the angle that we're going to talk about is always going to be the reference angle when it comes to inverse trig functions. So let's consider what that angle is going to look like. Now, if I establish the relationship for cosine as being x over y in the as x over r in the unit circle, and I know that r is always equal to 1. In the case where inverse cosine is equal to 0, x is going to be equal to 0. And x is equal to 0 in an angle whose measure is 90 degrees. So at this point here in the unit circle, my coordinates are 0, 1. So my value for cosine will be 0. So the answer to this question is going to be 90 degrees. In the second question, I'm asked to find the inverse sine where the relationship is root 3 over 2. So I'm going to draw out my, and now remember sine is going to be the opposite value over the hypotenuse. Okay, so I'm just going to draw out a picture here. I draw my, and I'm going to draw this in the first quadrant because this is going to represent my reference angle. I draw out my triangle here. I know that the opposite side, or the side opposite the angle, here is going to be root 3, and this hypotenuse is going to be 2. Well, I know in this case that I've got a 30, 60, 90 triangle. This is going to be 1, so this angle here is going to be 60 degrees. Now we're asked to give the answer in both degrees and radians, so I write my answer in degrees as 60 degrees, and in radians in pi thirds radians. Okay, now we're going to use our calculators to figure out what the relationship is given an angle. So, I'm sorry, what the angle is given a relationship. So I have my relationship between the opposite over the adjacent side, which is tangent, is equal to 21.1. So what is the angle measure that gives us a relationship of 21.1 to 1 for tangent? So I turn on my calculator and I find the inverse tan button, so tan to the negative 1, and I type in 21.1 degrees, and I end up with approximately 87.3 degrees as my answer. So if I were to then type in tangent of 87.3 degrees, and this will be, again, your reference angle, I should get 21.1 as my answer. In the next question, we're asked to take this a step further. What we're going to do is we're going to find the reference angle, and then using an inverse trig function, and then we are going to, say sine of negative 1, sine of theta is equal to 0.41, and then we're going to apply it to where theta should be based on the dimensions of the angle that were provided as part of the question. So I'm going to rewrite this as inverse sine of 0.41 is equal to theta, because that's what we learned. And so I use my calculator for this. I find the inverse sine button, I type in 0.41, and I come up with an answer that's approximately 24.2 degrees. Well, 24.2 degrees is not between 90 and 180 degrees. So I need to figure out where, given the reference angle of 24.2 degrees, what my angle measure really is for the question in question. So between 90 and 180 degrees, I am looking at a value that's in this area. If my reference angle is 24.2 degrees, which in this case is here, then I can figure out that my angle in question is going to be 180 minus 24.2 2 degrees, which is equal to, if my math is right, 155.8 degrees. So just as an experiment, we type in then sine of 155.8 degrees, and we should get an answer that is approximately 0.41. So sine of 155.8 is equal to approximately 0.41. In the last question, we're asked now to bring all this together to find in an actual right triangle that we see, find the measure of angle theta, in this case in our right triangle. And we know that based on the relationship, this will be the opposite. What we have is the opposite and the hypotenuse. So opposite over hypotenuse is the sine relationship. So I know that the sine of theta is equal to 7 over 12. I can also rewrite this as the sine, inverse sine of 7 over 12 is equal to theta. So I go back to my calculator and I find the inverse sine function. I type in 7 divided by 12 in parentheses, and I come up with an angle measure that's equivalent to approximately 35.7 degrees.